B of this assignment. I did put the part A in my previous video. Here I'm going to do the part B. So the part B says passing variable data to subroutine through the stack. In the previous section, you were asked to write code which would print out your name on the PC. You did this by passing the memory address of what print via the MPU index register. However, it is quite possible that we need to supply more information than registers. We have available an alternative and more scalable approaches to use the stack to pass the information. Okay, we will first review the assembled code on the next page to understand how stack operates. The first line loads index with 10. This dollar sign represents the hexadecimal. So here in the code, here we have that bar right here. So and then txs instruction subtract, this one subtract one from it and move it to the stack pointer sp. Okay, so it subtract and move it to the stack pointer sp. The sp is now a dollar sign f, so it's because this is in hexadecimal. So you know the hexadecimal is like f is the maximum. After f you get 1 0. So if you reduce 1, you're gonna get f. Which is top of the stack grows backwards. So when we push the first value on it, it will stored at f in memory and sp will decrement to e. So until pc get to d013, the 55 will be stored at f, a at e, 34 at d, 55 a and 34. Okay, 34 at d and 12 at c, 11 at b and d0 at a will be pushed on the stack. We can see why 55 is before a, since we can see the individual instruction. However, when we push a 16-bit value on the stack, the LSB get pushed on first. LSB is least significant bits get pushed on first. The same applies to subroutines. When a JSR jump to subroutine or ESR branch to subroutine instruction is encountered, the MPU pushes the next PC on the stack and then change the PC based on the operand of the instruction. So we can see that D011 is pushed on the stack and then PC is updated to D013. When the MPU eventually runs RTS return from subroutine instruction, it will pull off the 16-bit value and store it into the PC. Okay, 1 second, I received a mail. Okay, so the next instruction will be at D011 and the SP will be C. We have to be careful with the SP to ensure it is RAM. In this example, the SP is initially set very low to illustrate potential problem. We can see that D011 jump back to D004, which D011 jump back to D04 JSR. Okay, where is that part? Okay, D04, which repeats pushing the same information on the stack. At some point SP will go effectively negative, reset back to $FFF or lower due to the unsaturated subtraction. It doesn't go below 0, and since the memory from D00 to FFF is read-only, the stack operation will not successfully write to this memory. When the MPU eventually encounters a pull or an RTS, it will be reading the value from ROM instead of what was intended to be stored, and we can expect the system to fail from this point on. The 68HC11 doesn't have any protection mechanism against this type of stack overflow, but it can trap illegal instruction or reset the system if the program doesn't reset a special timer in a given amount of time. We will discuss this in later lectures. From this section of this assignment, you will modify your serial text subroutine from the section A and use it in the last 16-bit of entries on the stack. After return PC in RAM, before return PC on the stack, specify the location sending would be at 1234, assuming D013 was printing function. To summarize the code, on the right show how we would pass a single value, a 16 in this case, to subroutine, but you can easily pass more pieces of information on subroutine returns. It is important to pull off those values so that stack doesn't overflow, as more subroutines are called later on. Some MBUs have series of instructions that can only add to ESP. For example, if you had to pass 20 16-bit values to a subroutine, we could push those 20 values, call the subroutine, and then pull them off the stack, or we could simply add 20 times 2 to the SP once the subroutine returns, far faster than pulling them all off the stack. This is what is done with languages such as C when they are compiled to assembly code. Or okay, open CSV and modify appropriately. Remember that SP points to the next available entry of the stack. The instruction TSX transfer SP to index actually moves SP plus 1 index, so that index will be pointing to the current topmost entry on in the stack, not the next empty entry. After this instruction, you can use index addressing to indirectly access entries in the stack. Your code should continuously send it worked trying again to the PC over and over again. To ensure you didn't accidentally damage the stack, let it run for a number of iterations to make sure it worked completely. So this is what has to be done. Let's go to the assignment. Okay, I'm gonna open this Prism 11. Okay, now I'm gonna open the part B. That's what we are doing. Okay, this is the code provided, and this is what we have right here. And I'm gonna go to the view serial receiver, and I'm running this code and see nothing happening. Okay, but is there anything changing here? Let's see. So here also nothing moving, only SP and PC are like going like this, nothing else moving. So let's see what's happening. Okay, so now this is the part we have to edit and make it work. Serial transfer SP1 to index. TXX does this. So now index is pointing to the last byte of the stack. Okay, so here is already mentioned TXX does this. We have to transfer SP1 to the index, so we put a TSX over here. TSX. Okay, now to make sure it's not giving any error, I execute and run. Yeah, it's running, no error, so it's working. Okay, the next part is asking, okay, the next part is the last bit entry is the return PC. 16-bit entry is the return PC. Okay, the next 16-bit is the what we are interested in. Okay, load ACCD from the memory pointed by index plus 2. So if you want to load ACCD, we put the comment LDD, and if you want to add 2 to the index x, then 2 comma x, it will add it. Okay, then move ACCD to index. So here a bunch of code things we have to be aware of. I bring it all from the microcontroller book. So here yeah, in the first one it says exchange D with X, XGDX. So there are like bunch of them. Like if you see, I have like around 10 page of these things available. So you can go through that one by one and figure it out. But this is the job we had to move. Okay, wait a minute. So what is the instructions here says? Move ACCD to index. As far as I can see here, exchange D with X. So X represents the index, D represents the ACCD. So XGDX works. Okay, now to make sure everything perfectly working, I'm gonna give a run for this. Okay, so it's working without error, but nothing really changing over here. Okay, now it's asked us to use your code from section A. Section A, I did it in my last video. So if you want to see that, you can go ahead and watch my last video, but I'm going to open the file. Section A, it should be somewhere here, I guess. Let me try this. Okay. Well, section A actually keep on printing my name. I'm going to make sure it works. So let's run this. And it prints my name and then stops. So I'm going to copy that. We are just interested in the part where the part under the serial text. So I copy this one until exit and copy this and paste it over here. Here it's a leave. Okay, now I paste it over here and let's give it a run and see if anything happens. Okay, I am seeing an error. It's a unexpected character and second directive. Okay, let's see what's the error. So the error is basically there's no if I put something in the beginning, it gives error. If I give a space like this, it works usually. So I'm gonna reset and run and BEQ exit. So if it's equals 0, we exit. Then here the exit is replaced with leave here. So instead of that, we change that one to leave. Okay. Now let's go ahead and run. Okay, so it's keep on printing I. And what we want here is we want to print out it work trying again. It should be printing again and again, but it's only printing I. It's because if you look at this, like for this one, if you compare the code previously, previous A part I have here, let's see what is changing. Okay, I reset and noticing here, and when I run, you see this part A is increasing and then every part was increasing. Yeah, okay, that's how it ran. To see that again, we have x increasing, a increasing, d increasing. So this one has to happen. Something has to, increase and run. But when I have b code and I'm resetting and give it a run, nothing really changing here, right? It's in the same exact location, nothing changing, nothing happening. So we have to do something to change. So I'm looking at I have only control of like serial text is a part. I have to take control. Initially we have transfer x and then ldd load this one. Move ASCD to index, and after that we copied code from x and a. So here what's happening, ld write your code. Okay, this one happening, beq leave, jsr in x. So here we have increment of x, but it's not happening here. Okay, to figure that one out, I can see I can set a okay, let's see. I go to this jump and I'm going to put a breakpoint here and I'm going to give it a run and see what happens. It comes right here and then go back to serial text and stuff. So here what we can do is we want to make this index happen, right? Okay, so what let's try a loop. Okay, loop 0 here, and instead of jump to serial text I put a loop 0 here. Okay, now execute, reset. I had to remove this breakpoint and remove this breakpoint and then give it a run. Now it's perfectly working. So it was a problem that x wasn't increasing, therefore nothing else was working, right? So that had happened, like just because we loop again and again and again, now x is increasing and other values are changing as well. It's because we did a lot of things, like here we move ACCD to x, and yeah, as x changes everything is changing. Okay, so that's what has to happen and that's happening. And we give it a number of run, and if it works perfect, then that's it. That's what has to be but that's what has to happen. Okay, now let's try again. So initially the number is coming right here. You know what I'm gonna do? I'm gonna close it and try open again, because sometimes it comes like, but when I close and open it works. So I'm gonna serve it over. It's already served. Close, exit, close this, and open this again. File open, and I was doing it at 36. See, let's see. Open B, and in the B we have done this thing. Okay, now I'm gonna get the serial receiver, run this code. It worked, trying again. It worked, trying again. Okay, so it's keep on running as we expected. That's what has to happen. And that's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.